Okay, so I'm going to be taking a look at the final exam for spring 2017. This is question 7, sorry. This is a volume of revolution question. Okay, so let's set this up. So we've got the AB region in the first quadrant, so we're kind of told where to look. It's bounded by the graph y equals x plus 1, and the graph of y equals radical minus x plus 1, and the line where x equals positive 1. Okay, so I want to be able to visualize that, how I'm going to set that up. So I'm going to come up with a plot. So when I do this plot, I'm going to be zeroing in. This is x equals 1, x equals 2. So it's right here. So before we plot it out, actually, let's take a look at where do these two functions intersect each other. So I'm going to set them up. So x plus 1 equals radical minus x plus 1. Okay, so what I want to do is get these so that I can combine them. So I need to square both sides. So when I do that, so I'm going to get x plus 1 quantity squared equals minus x plus 1. Okay, I'm going to FOIL this out, which is basically equal to x squared plus 2x plus 1 equals minus x plus 1. There's a plus 1 in there. I'm going to add the x, and the 1's cancel. Okay, so basically we're looking at x squared plus 3x equals to 0. And I'm going to factor out an x plus 3 equals 0. So I've got x equals 0 and x equals minus 3. Okay, so this right here is a solution to where these two, where this equation, right, is equal to its, where it's a solution to our quadratic equation here, but it's not a solution for where these two functions are going to be intersecting each other. We'll see that when we graph it out. So when I graph out first the equation of y equals x plus 1, so I've got this. Here. So this is radical minus x plus 1, x plus 1, and then we're told to bound it by this right here. So we're looking at this is what I had been picturing. Because we're told to bound it by a line, x equals positive 1, okay, where all three of these things, okay, come together. So right here is the region that I want to be revolving around the various axes that we're working with. So I was given this x equals minus 3. That's not really valid. What we're trying to do, it's also, we were told to take a look in the first quadrant. So I'm not going to be thinking about other stuff. Also, we can kind of see that it's not going to be intersecting it on x equals minus 3. So that one I'm not going to worry about. And I'm just looking here, which means that my bounds of integration are going to be from x equals 0 to x equals 1. Okay, you can kind of see, because we're also told to bound it by this line, x equals 1. Okay, so our bounds of integration are from 0 to 1 as we go through whichever method that we're talking about. Okay, so now that we have that set up, let's take a look. So part A says we want to go about the x-axis. Here's our x-axis. I'm going to go about this line right here. So when I go about this line right here, right, you can imagine, right, I've got this, kind of a shaped curve that's happening here. I want to be taking a look at on my disk or washer method. Okay, this is based on pi r squared. Okay, I'm going to be integrating that dx. Okay, so if I go around the x-axis, when I set this up, I need to think about my upper radius. So the upper radius is going to be this function right here. This is my outside radius. My outer radius, okay, is based on this linear graph. That's x plus 1. My inner radius, right, is based on this graph right here. So this one here is radical minus x plus 1. Just remember, we're going to go the integral from 0 to 1. I'm going to go pi, our upper or outer, we've been calling it squared, minus from 0 to 1 pi squared. And these are both dx's here. Okay, so let's fill in what we have. Squared isn't too obvious. And this is our volume. So volume equals, I'm going to go from 0 to 1 pi, my upper, x plus 1, quantity squared, dx, minus my inner, 0 to 1 pi, radical minus x plus 1 squared dx. And then that's it. They didn't ask us to evaluate it or do anything more with it, so I'm just going to leave it as is. And you may also see it in the form where I factor out the pi. So I'll write that out so you can see what that looks like. X plus 1 quantity squared minus radical, or radical minus x plus 1 squared dx. Okay, notice how each one is individually squared. Okay, and then I subtract those two. So I'm never going to get a case where I've got these two quantities squared. Okay, not in this particular case here. Okay, so that was part A. Part B says we're going to go about the line x equals positive 2. Let's draw that on our graph. So I've got this line x equals positive 2. This is where x is equal to positive 2. That line is a vertical line. So I'm going around this graph right here. So I'm going to go this way. So I'm going to go this way around my graph. Okay. So as I go around, right, I'm creating, I've got a circumference, the circle that I'm actually creating as I go. Okay. So I need to be able to think about our shell method. The shell method says I'm going to go 2 pi r, because that's my circumference. I'm creating a circumference as I go around that circle. 2 pi r times the height times the thickness of each tiny little circle that I'm going around. This is going from A to B. A to B comes from our intersection points here. What's the bounds on that? So let's calculate out the different pieces. So our radius. Okay. So the radius is going to be my axis of revolution minus my x, 2 minus x. I'm going around here. This, normally on the shell method, right, how far out from A to B, how far out am I actually going? Okay, so that kind of gives me that radial point. But I need to go around this axis right here, so I'm going to be looking at this axis of revolution minus where am I actually at in terms of x? Okay, so that's how we need to think about our radius. Remember, when we did the lecture notes for chapter, I think this is 2.5, there's a whole bunch of pages at the very end of the lecture notes which talk about how do you think about the radius when you're calculating these things out. So you can take a look at the lecture notes for that for a reminder. So for the height, I'm looking at essentially the area of this region. So I'm looking at my upper function minus my lower function. My upper function is my linear x plus 1 minus my lower function minus x plus 1. There. That forms the height. I'm going to plug that into here. My radius gets plugged in from there. Okay, so let's fill it all in. So our volume, revolution, we're going from 0 to 1. We found that out before. 0 to 1, 2 pi for our circumference, r. 2 minus x is our radius. Our height, our upper function, x plus 1 minus radical minus x plus 1. And then don't forget your dx. And that's it. They didn't ask us to evaluate it. They just asked us to set it up. So that's our shell method. Shell method is used for going around a vertical axis. Okay. The disk or washer method is used for going around a horizontal axis. Now, I can use the disk or washer method going around a vertical axis. It's just a lot more cumbersome. So I'm not going to worry about it. I'm going to focus on the shell method. It's much more straightforward.